Hello, my name is Martin Shimada. I'm presenting to you a guide on how to make a simple permanent magnet DC motor. By the end of this video, we'll have a working example for demonstration purposes. We'll have a positive lead, a negative lead, and then to conduct current, we'll be using a spool of magnet wire. Magnet wire is simply copper wire with a non-conductive insulation surrounding it. We'll have a stand to attach all of our components, and our power source will be a 3.7 volt battery, or two 3.7 volt batteries, or three 3.7 volt batteries. Before we construct this motor, let's look at the diagram and discuss some problems. So we have our north-oriented magnet facing up, so the flux direction is up. We have the positive terminal of our battery with a wire attached and creating a current leading through our coil following this path, exiting at this side and returning to the negative terminal of our battery. And so we have a force here and here that's going to create a torque and spin our motor. Let's look at the side view. So there's our magnet. Current coming out, current going in, creating a force to the left and a force to the right by Faraday's law and Bill's law. That's going to create a rotation, but there is a problem. Let's talk about that. Before we get to our potential problem, let's look at our ideal starting situation. We still have our flux direction is up. We have current coming out at the bottom of the page, going in at the top of the page, and by the right-hand rule, a force is being created to the left at the bottom and to the right at the top. This provides an angular velocity to our motor and is going to make it spin. However, 90 degrees after this situation, we start to run into a problem because our forces are going to be aligned, and this could create a lock condition where we're just really creating a short circuit, and which will probably overheat and burn our motor up. In a real motor, you would use a commutator, which would allow you to change the direction of the currents in the motor, but this presumes you have multiple coils, which we don't. So we'll be creating a phony commutator where our magnet wire, which is in contact with our leads, is going to have only half of the insulation removed. So as it spins, half the time, it's getting zero current. This is going to create our commutating effect. Here we have our fully assembled motor. There's our 3.7 volt battery in the front. There's the north pole of our permanent magnet facing up, as labeled with north. You can see our coils are oriented up and down. The first winding goes over the top and then around under the bottom. It's wound clockwise, in other words. We have our positive lead to our positive terminal, and negative lead not connected but lined up with our negative terminal, which is what we're going to connect to see if the motor spins. It does spin. We'll let it go for a little bit and then let it wind down, and we'll switch back over to the side so that you can see that the direction of rotation matches our diagram. Thank you.